In this video, I am going to explain you some more examples on designing NFAs. So here I'll give two examples on this video. To accept strings starts with 01 and also to accept strings ends with 01. We'll see the examples. So here design NFA to accept strings which starts with 01. That means that NFA should accept all the strings if the string starts with 01. So initially what you need to do, you need to write first the language of strings. So what is the string? What is the minimum string? The minimum string is 01, which starts with 0. 0, 1, 1, 0, 1, 0, 0, 1, 1, 0, 1, 0, so on. So this language is infinite language because we can write infinite number of strings which starts with 0. So here we have to understand one thing, that the string starts with 0. First of all, draw the minimum diagram for the minimum string. What is the minimum string here? 0, 1 is the minimum string here. So let us draw the design for the minimum string. So here let us suppose Q0 is the initial state. Let us suppose Q0 is the initial state. And for the minimum string 01, on taking 0, we are moving to Q1. Again, upon taking 1, we are going to Q2. So this will be the final state. This will be the final state. That means as long as you see a 0 and 1, you are coming to the final state. So this is the diagram for the minimum string. Now after 0, 1, you can have any number of zeros and any number of ones. So first of all, initially you need 0, 1. After seeing 0, 1, you can have any number of ones and any number of 0 combinations. You may have 0, 0, 1, 0, 1, 1. You can have anything. It is not considerable. It is not considerable. Here we have to look for only 0, 1. So whenever immediately you are seeing 0, 1, you are going to the final state. After 0, 1, for any number of zeros and for any number of ones, we are on the self state. That means on the state Q. So I already explained. In NFA, we have the flexibility to design your required string. But when it comes to the DFA, definitely you have to define every symbol on every state. But in NFA, you are not required to define all the symbols and all the states. That makes the design easy. So that's why here on Q0, I am not explaining what happens if if the string starts with 1. If string starts with 1, we are not caring. The string is terminated. That means we are not moving. So here I am not explaining what happens if any 0 comes after the 0. That means I am not defining 0 on Q1. So that means in NFA, you are not required to define all the input symbols on all the states. You just look at what is the required. What is required? The string should start with 0, 1. So here this is the required part. So whenever there is 0, 1 in your string, you are directly going to the final state. After 0, 1, you can have any number of zeros, ones and zeros combinations. That we don't care. Just we will rotate on the same state, that is self loop. Now this is the diagram for accepting the strings which starts with 0, 1. So now you can see how flexible the NFA is. If it is DFA, you have to see all the possibilities. But in NFA, you are just looking for if the string starts with 0, 1. And we are not looking for the remaining symbols on Q0 and Q1. So if you want DFA, we have a equivalence theorem that every NFA has an equivalence DFA. With that procedure, we can convert this NFA into DFA so that we will get the required DFA. So I hope you are all understanding. Please look at what is required. So here in the given problem, the requirement is string should start with 0, 1. So for that only, I wrote the diagram. For this only, you just draw the diagram. 0, 1. You forget about the remaining things. That means what happens on if 1 comes on Q0, what happens if 0 comes on Q1? You just leave. Why? Because we will see all the possibilities when you are deriving the string. If any one of the path is leading to the acceptable state, then your string is accepted. Otherwise, your string is not accepted. Let us take one example to accept the string. Let us take, let W is equal to 0, 1, 0, 0. Let us suppose. So, is it acceptable string or not? Yes, it is acceptable string. Why? Because the string starts with 0, 1. But we are not supposed to say it is acceptable. The machine should say whether it is acceptable or not. So, initially you are at Q0. On seeing first 0, on Q0, where you are going? You are going to, on seeing the first 0, you are going to Q1. You are going to Q1. On seeing the next input symbol 1, you are moving to Q2. You are moving to Q2. After that, on seeing the next input symbol 0, you will be on Q2 only. Again, you are looking at 0. Again, you will be on the state Q2 only. Now you have only one path. In that path, the last state is Q2, which is acceptable state. So your string is accepted. Acceptable state. So the string is accepted because the string starts with the symbol 0, 1. In this way, you have to check whether the string is accepted or not. Similarly, we will take one example. Another example, let W is equal to 0, 0, 1, 0. Now we can look at here the string is not starting with 0, 0, 1. It starts with 0, 0. Now it is not acceptable string, but we have to check. You have started at initial state Q0. On taking the symbol 0, we are moving to Q1. Again on Q1, you have seen the symbol 0. On Q1, on seeing 0 on Q1, you have not defined any moves. You have not defined any transition. That means the state is terminated. The path is abruptly stopped. So now it indicates that the string is not accepted. You don't have any move on taking 0 on Q1. So that means you are unable to move. You are unable to take any decision. You have stopped abruptly. So that means the string is not accepted. So in this way, you have to check two strings. One is for acceptable string and there is for rejected string. Next we will go with another example. In this problem, design NFA to accept strings which ends with 0, 1. In the previous problem, which starts with 0, 1. In this, the string shall end with 0, 1. So first of all, you have to observe the constraint. Here, the constraint is the string shall end with 0, 1. Now, as usual, first of all, you have to write the long ways of strings. So what is the minimum string? The minimum string is 0, 1. 1, 0, 1. 0, 0, 1. 1, 1, 0, 1. 0, 0, 1, 0, 1. So on. So like that, you can write infinite number of strings which ends with 0, 1. So which should end with 0, 1. So you have to write first of all the minimum diagram for the minimum string. So initially I am at Q0. On seeing the input 0, I am going to Q1. Again on taking the input 1, I am going to Q2. Now I am making Q2 as the final state. Here I am supposing that 0, 1 is the end. So before 0, 1, you can have any number of ones and zeros. You can have any combination of ones and zeros. So as long as there are many number of zeros and ones, I will be on Q0. at one stage for last 0, 1, I will change my state and I'll reach to the final state. See, 0, 1 is the end. It should end with 0, 1. Before that, you can have any number of zeros and ones. I will be on the initial state Q0 for all these zeros and ones. At one stage, at one particular stage, I will go to by looking at 0 and 1, I will go to final state. This is the way of constructing the NFA. As I already told that you are not required to define all the symbols and all the states, and you are not required to worry about. So what happens if 0 comes on Q0, and what happens if 0 and 1 comes on Q0? You just leave it. Here you think that at one stage, if your string is really having 0 and 1 at the end of the string, you are going to Q2. Anyway, we will check all possible paths. If any path is leading to final state, then your string is accepted. In that way, you have to draw the NFAs for the given strings. Now we will look at some example. Let us take a string W is equal to 1 0 0 1. So here the string ends with 0 1, so that the string is accepted, but the mission should accept it. So when you start with Q0, initial state is Q0. After looking at first one, you don't have any other alternative way. You have only one path, that is Q0 only. Q0 only. Next, after seeing this 0, either you can go to Q0. That means you have two paths. You have two paths. One is either you can go to, you will be on the same state Q0, or you can go to Q1. So let us suppose we will go in this way. We will go in this way. So on seeing the next input symbol, this is Q0. On seeing the next input symbol 0, you are going to either Q0 or Q1. Q1. On seeing 1, suppose if you go like this, on seeing 1 on Q0, you are going to Q0 only. You are going to Q0 only. Now this is not acceptable state. The path is not acceptable path. Suppose on seeing 1 on Q0, Q1, where are you going on seeing 1 on Q1? You are going to Q2. You are going to Q2. Now this is accepted. This is acceptable state. So 0 0 1 0 0 1. That means we are going in this way. Suppose if you see this one, and this one, and this one, this path is leading to the final state. Now suppose when you come here 1 0, what is the next one? Next one is 0. On seeing 0 on Q1, where you are going? You don't have any state. On seeing 0 on Q1, we have not defined the 0 symbol on Q1. So here you are stopping. You are abruptly stopping. So this way, say here, in out of all these paths, one path is acceptable path. So this is final state. This is final state. Final state. So the string W is equal to 1 0 0 1 is accepted. Accepted. So this is a way of finding whether the string is accepted or not. Next we will take one more string to reject the string. Now we will look at another example. Let us consider a string W is equal to 1 0 1 1. So here clearly the string is not ending with 0 1. That means this string is not accepted, but we have to check through the diagram. So initially you are at Q0. On seeing the first symbol 1, you are going to Q0 only. That means you will be on the same state. On seeing 0 on Q0, you are going to either Q0 or you are coming to Q1. You have two options. Again, let us suppose we will go in this option. Again, on seeing 1 on Q0 or 1 on Q0, you are going to again Q0. Again, on seeing another 1 on Q0, again you are going to Q0 only. Now Q0 is not acceptable state. This is not acceptable state. Let us look at the remaining. So 1 0. Suppose on seeing 1 on Q1, you are going to Q2. After that, again you have one more symbol, that is 1. On seeing 1 on Q1, you don't have option. That means you are abruptly terminating. That means this is also not accepted. Even though you are not here, you have reached the final state. After on Q2, you have one more symbol that is not defined. So you are stopping. So none of the state is taking the string to the final state, so that the string is not accepted. So the given string W is equal to 1011 is not accepted. So this is the way of designing NFAs for the given problems.